Bismillahirrahmanirrahim. Dear students, Assalamu alaikum. Hope all of you are doing well by the mercy of Almighty Allah. I'm Irene Parveen. Welcome to our regular online chemistry first paper class, English version arranged by KPB School and College. Today, I would like to discuss chemical reactions and green chemistry, rate of reaction, effects of various factors which influence the rate of reaction under chapter 4. The title of chapter 4 is Chemical Changes. At first, I would like to discuss chemical reactions and green chemistry. You know, during chemical reactions, many harmful and hazardous wastes are produced. For example, reaction solvents and many byproducts that might evaporate into the air or leach into the groundwater. The hazardous chemical wastes may cause the existence of plant and animal kingdoms in danger. Green chemistry encourages the design of products and processes that minimize the use and generations of hazardous substances. So, we can define green chemistry in this way. Green chemistry is the design and implementation of chemical process in different industries and reduce waste and minimize or eliminate the generation of harmful and hazardous chemical substances towards environment. Here some words are important: reduce waste and minimize or eliminate generation of harmful and hazardous chemical substance. That means the main purpose of chemical green chemistry is to reduce waste and minimize the generation of harmful and hazardous chemical substance towards environment. Paul Anatas and John Warner C. Warner developed 12 principles of green chemistry in 1991. There are 12 principles of green chemistry. Number 1, preventing waste. Preventing waste, that means it is better to prevent waste than to treat or clean up waste after it is formed. Number 2, minimizing atom economy. Synthetic methods should be designed to maximize the incorporation of all materials used in the process into the final products. That is, we have to try to use such synthetic process that produces maximum product from the reactant. And number 3, using less hazardous processes. Methods of chemical synthesis should use non-toxic reactants and generate non-toxic waste. This type of synthetic method will make the lives of industrial workers and surrounding environment free from danger. That means we use such type of uh, reactants and methods which are non-toxic. Now, I would like to discuss rate of chemical reactions. The rate of change of concentration is called the rate of chemical reaction. That means decrease in concentration of the reactants or the increase in concentration of the products per unit time is called the rate of reaction. Look at the figure, please. Here, let at time t1, the concentration of a reactant is C1, and at time T2, the concentration of reactant decreased to C2. Look here. After some times, the concentration of reactant decreased to C2. Therefore, at time T2 minus T1, the decrease of concentration of reactant is minus Dc. Here minus sign is used because C1 is greater than C2. So when we take C2 minus C1, then we get minus sign. At unit time, the decrease of the concentration of reactant. So at unit time, the decrease of the concentration of reactant is minus dc by dt at unit time, where C is the concentration and of reactant, and this is the I write it clearly, and this is the mathematical equation of rate of reaction. The mathematical equation of rate of reaction is minus dc divided by dt, and similarly at time t1, the concentration of product at time t1, the concentration of product is x1. The concentration of product is x1, and at time t2, the concentration of product is x2. Then the rate of reaction is dx by dt. Here the sign is positive. Here, look here, the sign is positive, dx by dt, because here x2 is greater than x1. So we can say rate of reaction equal to change in concentration divided by difference in time. Change in concentration, it may be change in concentration of reactant, or it may be change in concentration of products divided by time difference. And the unit of reaction rate, concentration by concentration by time is the rate of reaction. So unit may be unit is the unit of rate of reaction mole per decimeter cube per second, or mole per liter per second. These are the units of rate of reaction. Now I would like to solve a mathematical problem related to rate of reaction. Look here. The question is, if hydrogen peroxide solution is added to hydrogen peroxide solution is added to potassium iodide solution. Hydrogen peroxide solution is added to potassium iodide solution. Iodine is liberated 10 to the power inverse 5 mole per decimeter cube in 10 seconds. That means concentration 10 inverse 5 mole per decimeter cube. What is the rate of reaction of iodine production? You know the rate of reaction equal to concentration versus time. So here after 10 seconds the concentration of iodine equal to 10 inverse 5 mole per decimeter cube, and initial time, that means when reaction is started, initial time t equal to 0 and final time t2 equal to 10 seconds. So rate of reaction, here we find out the rate of reaction from the concentration of product, that means dx by dt equal to concentration of product is 10 inverse 5 and time is 10 seconds. So 10 inverse 5 divided 10 second equal to 10 inverse 6 mole per decimeter cube per second. This is the result of this problem. And you have to practice other mathematical problems related to rate of reaction from your textbook. Now I would like to discuss factors influencing the rate of reaction. Some factors influence the rate of reactions. These are concentration of reactants, temperature, pressure in case of gaseous system, and light, surface area of reactant, and catalyst. These factors influence the rate of reactions. Among them, today I will discuss only effect of concentrations of reactant. Effect of concentration of reactant. From the figure, we can see that the rate of reaction, here is concentration and this one is rate of reaction. From the figure, we can see that the rate of reaction increase in the concentration of the reactant increase. That means rate of reaction increase if concentration rate of reaction increase if concentration of reactant increase, because As the concentration of reactant increase, the probability of collisions among them also increase. So we say that rate of reaction increases linearly, look here, linearly, as the concentration of reactant increase. Now we have to explain the effect of rate of concentration of reactants by an experiment. The effect of concentration on the rate of reaction can be easily demonstrated by an easy experiment. At first, we take 25 centimeter cube solution of sodium thiosulfate having a concentration of 0.1 mole per decimeter cube in a beaker. Look here, at first we take 25 cubic centimeter sodium thiosulfate solution, Na2S2O3 solution, and its concentration is 0.01 mole per decimeter cube. Now place the beaker over a white paper with a cross sign. Look here, this is a white paper and this is the cross sign. We place the beaker on the cross sign. Then we add 5 cubic centimeter dilute hydrochloric acid to the solution and start stopwatch to measure the time. The two reactants, that is sodium thiosulfate and HCl, react together and produce yellow color sulfur, and as the reaction will proceed, the amount of liberated sulfur will increase. After some times, the liberated sulfur will cover the cross point. After some time, the liberated sulfur will cover the cross point. Gradually, sulfur covered the cross point and lastly fully covered the cross point. The time of disappearance of the cross point is also recorded. Here we record the time for disappearing of the cross point. And we see here, after sometimes after starting the reaction, time is passed and the cross point is disappearing, and lastly finally when the product is formed fully, then the cross point disappears fully. And if we take this procedure 5 times with different concentration of sodium thiosulfate, and take the data from the data analysis, we can see that higher is the concentration of sodium thiosulfate, lower will be the time to reach identical point. Look at the table, please. If concentration of sodium thiosulfate increase, then time of disappearing cross point is decrease. Concentration of sodium thiosulfate increase, gradually time is decreased. When concentration of sodium thiosulfate is 0.01, then time is 98 seconds. But when some concentration is increased, that is 0.02, then time will also decrease, only 51. In this way, when concentration is 0.1, that means reactant concentration is 0.1, then time will decrease only 10 seconds. Only 10 seconds. So we can say higher is the concentration of sodium thiosulfate, lower will be the time to reach identical point. So rate of reaction increases linearly with increase in concentration. That means rate of reaction increase with increase in concentration linearly. So we can say minus dC divided by dt is directly proportional to C. That is minus dC by dt equal to Kc. Here K is proportionality constant when C is 1 molar. When C is 1 molar, then dC minus dC divided by dt equal to K when C is 1 molar. Therefore, we can say the rate of 1 molar concentration of reactant is called rate constant. The rate of 1 molar concentration, that means when C is 1 molar of reactant, is called rate constant, that is K. That is when C is 1 molar, then dC minus dC divided by dt equal to K. অর্থাৎ that means rate of constant is equal to the rate of 1 molar concentration of reactant. No more today. Hope this lecture was beneficial for all of you. You know the wave of corona is on rise. So please take better care of your health and your hygiene. Take care. Bye.